Hey everyone, in this video I'm going to be talking about the Grignard reaction and mostly centered around the mechanism of the Grignard reaction with some other notes. So just briefly we're going to be going over again the mechanism, how to make it, when to use it, when not to use it, and we're going to be noting some solvents and some other notables. So without stalling too much, let's get into our mechanism. Okay, so let's say we have some starting material, so some ketone, and we're changing it into this. So how might we go about doing this? Well, this is the Grignard reaction. So some things to note about recognizing when a Grignard reaction has happened is that over here in our reactants we have a ketone, but over here in our products we have what is now an alcohol. So we've put on a proton, so that means that we're going to have to add some sort of an acid. That's a good clue in. And then we also have some alkyl group. In this particular case we have methane that was attached to our carbonyl, it looks like. And so we're going to have some way of attaching a carbon group. And so the Grignard reaction, well, this reaction is characterized by two steps. The first step being our actual Grignard, so we call that, in this case, CH3, and then followed by magnesium bromide. And then the second step doesn't matter too much, just some sort of acidic H. So we're going to be adding a proton in the second step. So let's talk about the mechanism. So here we have our ketone and our generic R groups. And let's draw our first reagent, which is, we said, the actual Grignard. Okay, let's talk about the mechanism. So how do we treat this Grignard? Well, it's often seen best treated whenever we call this CH3 or whatever alkyl group you're using, just treat it as it's negatively charged. And then I guess you can go ahead and say that the magnesium bromide part is positively charged. Although we aren't going to be using that, so it's not super important to note that. So how does this magnesium bromide, CH3, all this junk turn into our product? Well, the first step, we need to recognize that over on our ketone species, we have a very strong partial positive charge because this ketone is, pulling all of its electrons up closer to the oxygen because it's more electronegative and it can accommodate more of a negative charge and all of that other good gen chem stuff. So we see that it'd be pretty easy to see that the negative charge is going to be attracted to this partial positive. It's going to attack that carbonyl carbon. We're going to see the electrons of this carbonyl double bond part being pushed up to our oxygen, giving us our first intermediate. So we have O minus. We've successfully attached our alkyl group. Oops. And there we go. And I guess you could say that this O minus is kind of being stabilized because we have a magnesium bromide that has positive charge. And so you can see that the O minus of the oxygen is actually kind of slightly being stabilized by our leftover parts of our Grignard. So what's next? Well, looking up above, we see that the second step is to add some sort of acidic proton. So, in most labs, I think anybody's ever going to use hydrochloric acid unless there's some reason not to. So let's go ahead and do the same for this example. We'll use HCl, which is a pretty strong acid, and we'll see that the oxygen is going to pull, or it's going to donate electrons to this acidic hydrogen. The electrons that were bonding the hydrogen to the chlorine get bumped holistically onto the chlorine, and you end up with our final product. So we've done it. We've created an alcohol and our methyl group attached, and don't forget our R groups. And we don't care about the yellow junk that's floating around in solution because we've made our product right here. Okay, so now that we've done this, it'd be important to know how to make a Grignard, because it doesn't do us any good if we can't even get it in the first place. So let me go over that real quick. So let's suppose we are starting out with, for the sake of consistency, we'll say some methane that is attached to a halogen. So we have bromomethane, and we're trying to turn this into our Grignard. So I've kind of given away a little bit of the answer. You're going to start with some halogenated alkyl group. To this, we're going to add simply magnesium solid. And so this might be in the form of churnings. You know, maybe you get like beads or whatever. But you add your magnesium and your halogenated alkyl group, and you create our Grignard. And this is just a good note. Usually it is done in ether. And I say usually, I really should say all the time, because Grignards are actually very sensitive to water. So let me write that as a note. So, very sensitive to H2O. And while we're on this note, it's actually probably good to say that they're just sensitive in general. And it doesn't have to be H2O. It can be anything else that's in your reactants. Okay, so you do have to be kind of picky on what you want to use your Grignard with, because if you have something like, you know, maybe you have two ketones, or you have a ketone and a double bond, or you have, you know, an acidic H or something, you really just need to consider all possibilities of where this CH3 minus could go. So noted that it's sensitive to water. So now it's good to know when to use it. Well, we do this on a different piece of canvas. So when to use. Well, a good way to describe when to use it would be to, I guess, analyze our first kind of picture I showed you guys. We had something like this, and we created an alcohol, and we created some methyl group attached, and then we just had our Grignard. I'm just going to do that, and then our acidic H. Well, you can kind of just look at our reactants, then look at our product, and we can realize that, well, if we want to add an alkyl group, it probably might be a good idea to go Grignard. You know, and maybe even if we want to create an alcohol, a Grignard wouldn't be all that bad either. Although I should let you guys know that there are much easier ways to create alcohols from ketones, and Grignards would definitely not be that favorable, but that's another video. So let me do another example to kind of drive this point forward. Let's say we have, you know, some chain, doesn't matter how long, and then we want to add some carbons to it. So this is one of the first reactions that you'll learn in organic chemistry that add to carbon chains more carbons. And so it's a pretty gold reaction, because there aren't too many that do it that you'll learn in organic chemistry. But so let's say we want to add, I don't know, how many carbons is that? That's 4. If we call that attached to magnesium bromide, and I should have done that in white, but it's okay. And then our acidic proton right there. So if we considered the mechanism and what we can expect to find on a product side, well, we'll get the same thing over here. This part isn't affected. You get our OH like that, and then we're adding 1, 2, 3, 4 carbons, and so I'm going to add 1, 2, 3, 4 carbons right there, and not forget our art group. So we've attached this group onto our parent, I guess, chain, or the beginning chain, whatever you want to call it. So here we've used a Grignard to extend a carbon chain. Again, like I said, you could use them, I guess, if you wanted to create an alcohol, although I'll just give you guys a sneak peek. Something better you could use is something like sodium borohydride. But again, we'll talk about that in a different video. So when would you not use a Grignard? Let's talk about that next. So when not to use a Grignard. Okay, so I've already mentioned that Grignards are extremely sensitive to several different conditions, so let me just give you one example. Let's say you have an acyl chloride, so something like this. Let me make that bigger. Something like this. And you're trying to turn that into that. And we'll call that R. Well, if we used a Grignard for this reaction, I guess you could say we'd get that to some extent. And the second step would be our acid. Unfortunately, what would happen is not just this. Because if you remember from the first slide, or the first canvas I had, we started with a ketone, and we attacked the ketone with a Grignard to create essentially, the alcohol and an alkyl group. Well, who's to say that it can't happen again? And so you wouldn't really want to use a Grignard for this, because what would end up happening is you have your R group, and just drawing that all over again. And we want to consider the Grignard. And H plus. And why don't I actually stop being so lazy? I'll actually call the Grignard what it is. So what would happen is we create what we have right here. And we have our chlorine leaving, obviously, that's our leaving group. And then who's to say it can't happen again, right? So I guess right again. And so you create this, which is obviously not which is obviously not that. So it's not a very effective way to make, for example, just what I have shown right here. And I can go ahead and say the side products. Do I have a yellow? Use a yellow. Plus HCl. And you guys can take your time to figure out where that came from. But okay, so we've gone over when to use it, when not to use it. So I'm about ready to end the video. I just want to add a few extra notes that would be helpful for this reaction. Okay, so just a few other notes. I already kind of said that it's very sensitive to water, so I'll just, I guess, reiterate that. Very sensitive to H2O and other functional groups. To that note, it'd probably be important to talk about solvents. So we would like to run this sort of reaction in some sort of inert solvent. So common ones are used, I think, most often for Grignard reactions are, you'll see THF, you might even see some diethyl ether, and just really, I guess, any other ether. So remember, it is a strong nucleophile, so I'm going to write that in red to emphasize. Very strong nucleophile. What else could we say? It's okay. What about the double attacking? So watch out for double nucleophilic attack. And that was like that acyl chloride example I had. And I guess another thing that we can note is that it's helpful to think of Grignards as if they are such. So we had where we just have a negative charge on our alkyl group and a positive charge on our Grignard group, or I'm sorry, on our magnesium bromide group. And I'm going to do another note just real quick up here. I've realized I've only used methyl Grignards, but you could really use any combination of Grignards. You could do ones that go up all the way to like butane or whatever it is that you need. MGBR, so I'm all over the place. So yeah, just some other consider points that might be helpful to think about whenever you're dealing with a Grignard reaction.